Hello everyone, welcome to Skilled Dev. Trey here, and in this lesson, we're going to implement a stack from scratch. The constraints on our stack is that it needs to be built using a linked list. It needs to implement the methods peek, pop, and push. All these operations should be in O of 1 constant time. And since we're using a linked list, this shouldn't be any trouble. Linked lists themselves operate on the items at the end, which is exactly what peek, pop, and push do, and they do so in constant time because it's only updating a pointer. And the final constraint is that our stack should operate in LIFO order. And LIFO order is fundamental to a stack, and it means last in, first out. So the last item you add is the top item. It's the first one you're going to operate on, first one you're going to use anytime you use the stack itself. So let's visualize our stack. The stack itself maintains a stack.lastPointer, which points to the last node, or the top node in the linked list, which is the top of the stack. This node here is a node that has the value 8 and has a pre-pointer that points to the node before it. This node points to the node before it, and this is the last item in the stack, the bottom item, which was the first added, and its pre-pointer actually points to null. And the reason we're using a pre-pointer instead of a next pointer is to be a little more idiomatic with what a stack is. The last item added is the top item, so the one before it, the previous one, is the node in the linked list. So it doesn't change what the prev or next means, it's just an update to the variable naming. The first method we want to implement is stack.peek, and it just returns the last item in the stack, that top item. And notice that the stack isn't updated, it only returns the item itself so you can use it. If we want to add a new item to the stack, we call the stack.push method. Here, we set an item to a linked list node with the value of 17. We call stack.push to add it to the stack. And now we update the stack's last pointer to point to this new top item, this new last item. Its pre-pointer now points to the item before it, which was the last item before we added this new one. If we want to remove the top item, we call the stack.pop method. And what it does is take the item off the stack, return it, and then updates the stack.lastPointer to point to the next item. So now our 8 becomes the last item again, but the 17 was removed first because it's FIFO order. And now we're ready to implement our stack. Our stack is implemented using a linked list, so we've defined a linked list node as an object that takes in a data item, and this property stores the data of that node. We also have a pre-pointer, which just points to the item below it in the stack, or the previous linked list node. Our constructor will have a reference to the last item, which will initialize to null. The peek method will return the top item, the push method will allow us to add an item, and the pop method will allow us to remove the top item. As we said, peek just returns the last item. We want to peek at it, we just want to see it. So we simply return this.last. Very simple. Push allows us to add an item. So first, we store a reference to the previous last item. Then we say the last item is now the new node of the last item. And here, item just refers to the data that we're storing in the node. Now we need to update pointers. We already updated the last pointer of the stack, and now we want the last prev, its pointer, to point to the item before it, which was the previous last item. For a reference, we just return this.last. And now to remove an item, we first store a reference to the removed item, which is this.last. And now we check if the item was removed. If it's null, if there wasn't an item, then we don't update any pointers because there's not an object to set. If there was an item removed, we set the new last item to be the removed item, its prev node. And finally, we return removed item. So now we've implemented all three methods. Peek simply returns the last item. Push creates a new node, updates the last item, sets its pointer, and then returns this item. And pop removes an item from the list if it existed. And removed item updates the last pointer if we actually had a removed item if there were items in the stack. We set the last item now to the removed items prev pointer. And now let's run through an example. We're going to look at a stack as a web browser. So we'll initialize web browser as a new stack, and we'll start to visit websites. We'll push them to the stack. We go to Google, Facebook, and Twitter. And if we console log this, Twitter should be on the top of the stack. Then if we hit the back button, we pop an item, and Facebook should be on the top of the stack. Let's say we visit 2 more items, skilled dev and getconnected.com. If we console log this, our web browser should show getconnected.com on top. Then if we hit back, we should finally end with skilled dev at the top of our stack. And we can see that's what we got. Twitter on top with Facebook behind it. We hit the back button. Now Facebook is on top. We visit 2 more sites. Getconnected.com is on top. And then finally, we hit the back button one more time and skilled dev is on top. Our stack is working perfectly. And there we go. I hope you learned something. I hope you really understand how a stack works now from scratch and now can take this into your lessons. Thanks, and I'll see you in the next one.